All right, I think I got it. Yeah, looks good. All right. Hello and welcome everybody in the future, probably, if you're coming back to watch this stream. This is my first microscopy stream. So I'm just going to be putting some different stuff under the microscope and see what we find. I hope you have a coffee or a tea or a snack or something. Um, if not, this is going to be pretty chill. So let's just take a little while and look at some stuff under the scope. I have my 3D printer running in the background, so sorry if that's loud. If it is, I won't run that at the same time again. Yeah, there it is. I'm printing myself a new tripod for my phone. Ooh, that's good. Good latte. Okay. Stream looks good, so I'm gonna switch over to AmScope here until I don't need it. And let's go ahead and make sure we've got the live video running. Yep, looks good. All right. So the first thing I wanted to do, some slides here and some slips. First off, I found, just laying around my house, a bottle of drinking water that had been opened and was partially drank, but I have no idea how old it was. It's just left by my bed. So I wanted to take a little dropper full of that and get us a sample and just see what's going on in there, if anything. There we go. That's some pipettes. So let me switch back over and make sure we can see what's happening here. Okay, mostly. Can I take it down a little? Not necessarily. All right, I'm gonna move this back instead. All right, so we've got a slide here. We've got my bottle of water. I'm just gonna suck up a little bit and put maybe 4 drops on here. Move that back. And we'll take our this is a 0.16 millimeter glass, so I'm not going to use that. That's what came with the scope. I have a whole video about this microscope if you want to check it out. When I received it, it was not in the best of condition. It works, you know, but it was taken apart. Okay. We have a cover slip here. It goes there. So the way I'm going to apply it, let's make sure you can see this. I've got my slide here. I'm going to take my cover slip and I'm going to touch the side of it to the edge of that drop and it's going to disperse. And then as I drag it back and set this down, it's going to fill the whole area. We had a little bit of leakage. Let me get the towel. Put 1 too many drops. So I'm just going to touch this to the edge. Make sure you can see that. I'm going to touch it to the edge side, the cover slip, and get rid of that moisture. Don't want that anywhere near my microscope. There we go. All right, there's our prepped slide. Trapdoor and slide this into place. Okay, so we're in 4 times. I've got, I think, 2.5 times on the camera, so nothing crazy. Let's bring this up into range here. There we go. So that I'm guessing is the top of the cover slip. So I'm gonna keep going a little. I went too far. Let's go back. Well, I don't know. Let's this might be it. So let's stay here and take a look. Okay, here we go. Oh wow. I would like to just say that this is a new hobby for me. I'm not a microbiologist or anything like that. I'm going to be a software engineer, so this is all, just take it with a grain of salt and enjoy the ride with me. Let's flip this up and get some higher. Go up to 10x and see if we can find this guy again. There we go. I'm not quite sure what these are. Could just be some little globule of oils or something like that. And again, this is just drinking water, bottled drinking water that I found laying around somewhere. So I think when I focus here, this is the top of the cover slip, and then when I go down to here-ish, maybe. Yeah, I think that's the bottom of the cover slip. So somewhere in between the bottom of the slide, I mean. Increase the brightness a little. Ooh, here's a big piece of something. Get that in focus and refocus my right piece. Looks good. Just a piece of dirt or something, I'm guessing. Honestly, not seeing anything super crazy in here. Which is good, you know. Just these little blobs of whatever they are. Oh, there's a big one. Oh, look how they're coalescing. Yeah, so this is just some sort of oil or something that's suspended in this water. All those little blobs. Whoa. Oh, here we go. We've got something here. It's created all these air pockets around this fiber, what I'm assuming is probably a plastic textile fiber, polyester, or I can come over to the tip here and take a closer look. Where'd it go? There we go. Move my condenser up, try to get some more, oops, wrong direction, some more contrast on the contours of whatever this is. Interesting. Yeah, well, it could be a hair, or I don't know. Let's go up to 40x and see. In here. And hmm. Interesting. It's probably quite a bit smaller than a hair. Um, I don't really see any like segmentation like you would see with cells lined up. It looks more like one piece of something. And it does not appear smooth at a even smaller scale. I would bet that this is probably a synthetic fiber. Not super interesting, but you know. I would go up one more, but I don't have immersion oil yet, so we're not gonna mess with the 100x today. Well, that was a little bit underwhelming, but that's all right. We do have a couple fun things around here, so we can look at those. Stop and take a drink of my coffee. I do have. Oh yeah, I have a plate that's got a little bit of pinning on it. I can show you real quick. Little baby mushroom coming off the plate. Cute. This is an enoki plate that has this interesting fluffy growth. Almost looks like a puffball from far away. But it's fuzzy. It's got hyphae coming out. We could take a look at that. I'm not sure what's going on the surface. It's got like two different phenotypes growing out, it seems like. But it was from a liquid culture, so I assumed it would be one. Also, oops, sorry, I didn't mean to hit you. I also have what I believe was a Chlorophyllum molybdes specimen that I found in the wild and attempted to clone. It's got some bacterial contamination in there, but it's growing over it, so I'm going to wait until it grows all the way over and then try to take a transfer from this. What else do we have that we could bust into here? Yeah, we'll use this guy. This is a shaggy mane Coprinus comatus that I found locally, and I stored and dehydrated the spores, and then I took the spores to this sort of distilled water solution. And actually, we can take a look at that too, because I thought it was pretty cool seeing the actual spores germinating in distilled water. And then I took those to agar plates. Here's that water solution. So actually, let's take a look at that first. Since there was basically nothing in here, I'm just gonna pop this off, pop it down, and reuse this plate. All right, got my pipette. Open up this jar of shaggy mane spore goo and take just a tiny bit and wipe it over the surface. There are some large chunks on there, so I don't want to get any of those. Oops. This back. The rest of this. The first time I looked at these, I was shocked at how clean they appeared. Oh, I had two cover slips on there, so that's why there was some distortion. My bad. Alright, I'm just gonna wipe this off, hopefully. Getting my finger oils off of it. Should be wearing gloves for this, but that's okay. Alright. Also, I'm gonna dump out this water and get some fresh water. Alright, fresh water, nothing fancy, just tap water. I've looked at it a few times though, and it's clean tap water. There's nothing crazy in there. Oh, we're just gonna take a little extra and put, oh, I don't know, drop 2 or 3 maybe on here. And then we're gonna take our cover slip here and do that same procedure. Just touch it to the side and then swipe it down. And sides. You can kind of see there's yeah, there's stuff on there. So let's take a look. Oops, still a touch wet. All right. So let's go back down to 4x to start. Should be pretty obvious when we get there. Just see. That might be it. Let's take a look at that. Let's see if I can line it up to one of these chunks. Let's zoom in and take a look at this. I don't know what it is. Interesting. It almost looks like how simpler molds sporulate. But I can't tell if that's actually cellular at all. Let's go back to 4x. That's interesting because the last time I pulled this out and looked in here, there was just tons and tons and tons of spores. Maybe that's what these are, and they're just more dispersed. Let's try and zoom in and find some stuff. Maybe. You can see stuff flowing through the liquid under capillary pressure. You know, based on the shape and uniformity, I believe that these... Okay, I think we're back. Sorry about that, everyone. Computer decided that it was time to run an update, even though I have them turned off. So that's that, I guess. Back in, there we go. Okay, welcome back, everyone. We've got a little bit more time, so we can hopefully see if I can finish what I was trying to show you here. Let's head back over here and open up our camera. There we go. Alright, make sure it's on stream. Looks good. That's alright, we're still figuring it out. So, before we got rudely interrupted by this technology, I was showing you how I have this shaggy mane growing that I collected from a wild specimen last year. I put it in this distilled water slurry and this mix. And as you can see, there's some, we're at 40x right now, I think. Yeah. And this is some mycelia, and you can see it actually growing up to the spore here. Growing out of it, I guess, would be more accurate. Got a little floaty friend visiting. So yeah, you can see the hyphae growing out of the pore, which appears to be on top from this angle. And then they differentiate down the chain, and they split at these junctions. And if we look at these junctions, if I could go to 100x, we would probably see more clearly the clamp connections. Here we go. This bump right here is. Can you see my cursor? Ah, I guess you cannot. Here, let's see if I can make a snap and then draw on it. Center radius. Yeah, so this little section here, oops, I believe is an example of one of those so-called clamp connections. You kind of see one there in the center of the screen too, I think. And those connections form when two monokaryotes or haploid cells basically breed, and it becomes a dikaryote, where each cell actually has two genetically distinct nucleus. But this mycelium here is just proof that the spores that I collected did germinate inside this distilled water solution. There's some more up here, it looks like. And it's nice at this concentration being watered down too, because you can see that some of the spores very clearly did not germinate. Ooh, there's a nice shot. You can actually see that pore on the upper side there, where this would have germinated. And the first hypha would have pushed out of that pore right there. And this shape and color under the microscope were kind of the final identifier, if you will, that made me confident that this is a Coprinus comatus that I found. Along with the fact that it looked like a shaggy mane, and it deliquesced on the plate that I put on. So I am extremely confident that that's what I have here. Confident enough that I'm going to grow it to eat. But always do your own research. Make sure that you know what you're doing. I don't even want to claim that I know what I'm doing. I just have learned quite a bit, and I think that this is one of the easier, safer mushrooms to try to hunt. Oh, look at this. We've got some little friends swimming around here. I wonder what those are. Must be tiny. here, but you can see it that there's another spore, the exact same shape, that did not germinate. So definitely, and this was not a nutritious broth or anything, it was just distilled water. So, you know, it makes sense that a lot of these are not germinating. Ooh, what do we have here? I don't think that that's a germinating spore. I think that's just something stuck to it. What's up here? Can't quite tell at this resolution. Oh, here we go. We've got a couple spores here. One of these is very ovate. The other one is a little more squished. Ooh. Some junk. Oh, here we go. Here's a hyphal strand that doesn't seem to be attached to anything. Is it a hyphal strand? Oh, maybe not. Maybe that's just a fiber of some sort. Appears to be stuck to something else. I'm looking around trying to see if we can find one that's just hatched, you know, so to say. It looks like a tiny frog. It's not. It's dirt, probably. Interesting. Possibly seeing some Brownian motion there. I'm not sure. What's this? Malformed a little bit. Ooh, here's a good one. Kind of up at an angle. You can really see that pore there. On the left side, that circular divot. It's not really an opening, I don't think. It kind of gets pushed through when germination takes place. That's interesting. It's too bad I don't have immersion oil, because I find a bunch of stuff that I would love to get a closer look at. But that's alright. There's a real clear one. Now, I don't know what all the stuff inside is, but I'm doubtful that those are organelles. Those are most likely like lipid stores or something of that nature. I doubt that we could see at this scale any ribosomes or the mitochondria or anything like that. But maybe with the 100x, we might just be able to resolve some stuff like that. Ooh, what do we have here? Looks like we've got some mycelia, but no spore to be found. So this has been broken off from its spore. And this is really a good example of why getting a non-fruiting haploid out of a multi-spore syringe is, statistically, like, basically almost impossible. I'm not saying it doesn't happen, it does, but it's very, very, very unlikely because you have so many of these individual spores that are willing to germinate even just when exposed to water. And all it takes is, 2 of those individuals meeting up in order to produce a dikaryon. So it's very, very, very unlikely. And I see a lot of the time, I see people taking their multi-spore syringe and then, isolating multiple individuals based on agar growth characteristics and attempting to crossbreed those before they even go to fruiting. And I would say, yeah, that is a way to ensure 100% that you have a dikaryon that is going to fruit for you, but I really don't think that that step is necessary unless you're further down the line and trying to blend different traits or preserve certain individuals. Got 2 right next to each other here. I don't know, something about them. I love the way they look. The little pore, the little bump. They just look like tiny little olives, honestly. I love it. And it's just crazy to think that something so tiny could be, storing the information for an entire colony, an entire organism. It's pretty incredible to me. But since we know what the spores look like now, maybe we can do up another little plate and show some of this active mycelium instead. So do that. I'm gonna take my little tweezers here, get some isopropanol on this. Let these down here good. Alright, we've got this. I've got a slip over here. Just Wipe that down. Okay, so I'm gonna switch over and make sure we can see what's happening. I'm just gonna pop this open, and you guys can get a nice little look here. Very fluffy, nice, even growth. It's not really rhizomorphic, it's mostly tomentose, but I wouldn't really expect a shaggy mane to show too much rhizome without selecting for it. But basically, all I'm going to do is just from this leading edge up on the side here, I'm just going to kind of go underneath and pull it away. Just a little fluff worth. We don't need much. I'm going to try to get that to stick on the plate here. Drop the water to help us. Stubborn thing doesn't want to come off. Get in the center, you. Alright. Let's take our slip, cover slip. Again, just touch the side and then move it back and drop it down. Oop. Like watching it crawl across. It's neat. And then I'm just going to dab the bubble cells here. Alright, and that plate should be prepped. Or, whatever. Move this down. Agar all over my fingers. Let's take a coffee break before we look at this. It's good coffee. I love those little espresso machines. Okay, let's take a look. So this is the actual shaggy mane mycelium that was growing on agar. Oh, let's go back to 4x first. All right. So yeah, here we go. And then refocus. Nice. So this is that clump that we put kind of right in the center. Looks kind of messy at this scale, but if we come up somewhere like this section and switch up, you can see just thousands and thousands of individual mycelia. Contrast a little and see if we can't coerce a little bit better picture out of these noodles. There we go. Isn't that crazy? You can see how they're like piled on top of each other and they just bundle up. Stunning. Let's go up to 40x and look at this little patch. There we are. I mean, it really is just a mess of hyphae. So, you know, when we see, especially with rhizomorphic growth, when we see the rhizomes growing, we kind of equate that, or at least I do a lot of the time, to the hyphae, which I guess it is sort of, you know, like a large scale analogy for what the hyphae are doing. But these structures are so just incredibly minuscule that we don't often think about, you know, each one of those rhizomes having thousands or millions of individual hyphae. I am looking for clamp connections on these guys too. But, you know, like I said, I am very doubtful that I would have been able to isolate uh, any type of monokaryon from these spores. I would love, love, love at some point to be able to upgrade to a dark field scope, but wow, look at this. It's just like layer upon layer, and they all intertwine and interconnect. It almost reminds me of looking at, you know, like caving diagrams. Um, Look at how many different layers there are within a tenth of a millimeter, maybe less. Absolutely crazy. And these are the thin parts that we're looking at now. You know, it just gets denser and denser until you can barely even see through it. That's just crazy to me. Once I have some fresh fruits to play around with, I would love to try to get a look at the basidia in the gill structures. fat or something. I don't know. What do we have here? Oh, that's a nice little shot. So you can actually see in the center, in this darker